chirality is this property of molecules that they can come in mirror image forms. So like just like chiral literally means hand. So your left and right hand are what's called non-superimposable, because if you try to lay one on the other, you can't actually lay them directly on top of each other. So there's this sort of perplexing property of the chemistry of life that no one's been able to really adequately explain, that all of the amino acids in proteins are left-handed and all of the bases in RNA and DNA are right-handed. And yet the chemistry of these building block units, the amino acids and nucleobases, is the same for left and right-handed. So you have to have like some kind of symmetry breaking where you go from these chemistries that seem entirely equivalent to only having one chemistry take over as the dominant form. People take for granted the existence of chiral molecules at all. So if you look at chemical space, which is like the space of all possible molecules that people can generate, and you look at small molecules, things that have less than about 7 to 11 heavy atoms, so things that are not hydrogen, almost every single molecule in that space is achiral, like doesn't have a chiral center. So it would be like a spoon. A spoon doesn't have it's the same as its mirror image. It's not like a hand that's different than its mirror image. But if you get to like this threshold boundary, above that boundary, almost every single molecule is chiral. So you go from a universe where almost nothing has a mirror image form. There's no mirror image universe of possibilities, to this one where every single structure has pretty much a mirror image version. The origin of life transition happens around the time when you start accumulating. You push your molecules to a large enough complexity that chiral molecules become very likely to form. And then there's a cascade of molecular recognition where chiral molecules can recognize each other. And then you get this sort of autocatalytic feedback and things self-reinforcing. I think chirality breaks symmetry in time, not space. So we think of it as a spatial property, like a left and right hand. But if I choose the left hand, I'm basically choosing the future of that system for all time, because I've basically made a choice between the ways that that molecule can now react with every other object in its chemical universe.
Oh, I see.
And so you're actually like, when you have this splitting of making a molecule that now has another form it could have had by the same exact atomic composition, but now it's just a mirror image isometry, you're basically splitting the universe of possibilities every time. So the point of this sort of chiral transition that I'm pointing out is chirality is actually a signature of being in a complex chemical space. And the fact that we think it's a really generic feature of chemistry and it's really prevalent is because most of the chemistry we study on Earth is a product already of life. And it also has to do with this transition in assembly, this transition in possibility spaces, because I think there's something really fundamental going on at this boundary, that you don't really need to go that far into chemical space if you can to actually see life in terms of this depth in time, this depth in symmetries of objects, in terms of like chiral symmetries or this assembly structure. But getting past this boundary that's not very deep in that space requires life. It's a really weird property, and it's really weird that so many abrupt things happen in chemistry at that same scale.